Hello and welcome back. In this video, we discuss two important concepts used in fluid dynamic analysis, a system and a control volume. By definition, a system refers to collection of matter of fixed identity, which may move, flow and interact with the surroundings. For example, all the air in the Earth atmosphere is a system. A coffee in a cup is a system. A finite amount fluid flowing through a pipe is a system. A bleeding inflated balloon is a system. In general, a system refers to collection of matter having finite mass. On the other hand, a control volume refers to volume in space through which fluid may flow. The volume is purely a geometrical entity and it is independent of mass. For example, consider finite quantity of water flowing through a pipe. As we discussed earlier, flowing water is a system. A control volume is a geometrical shape having boundary surfaces. For example, consider a rectangular volume as shown in figure. We can imagine this arbitrary control volume can be fixed to a location within the pipe so that we can look at the flow conveniently through this geometric window. Choosing an appropriate window, we can imagine that the system is now flowing through this control volume. Consider another example of a jet engine. Possible streamline patterns of airflow into the engine and around are shown in the figure. In this example, finite quantity of air flows into the engine is a system. To study dynamic interaction of a system with the engine, an appropriate control volume can be chosen. A simple control volume chosen is shown in figure. It is a rectangular geometry fixed around the system. It is not necessary that the control volume need to be a particular shape. The geometry and location to which it is to be fixed will depend on how you want the analysis to be performed. Selection of control volume, as shown in the figure, may be useful than the previous one. We will discuss more about this in a later video. Hope you understand the concepts system and control volume. Thank you for listening.